Hello everyone, this is Mateo with Arcade.dev, and welcome to the tutorial on how to make your own custom toolkit. I'll be building a Mastodon toolkit that is inspired on our existing Twitter toolkit, or X toolkit. We'll be implementing a very similar functionality, but for the Mastodon social network. I'll go over on how to create a new OAuth provider, how to create a client for that OAuth provider, how to configure that into Arcade, how to program the tool, test the tool, evaluate the tool, and ultimately how to contribute the tool back to Arcade. So let's get to it. If you're developing a community toolkit that should be then integrated or contributed back to Arcade, then you need to be aware of how our repo is structured. Let's have a look. So this is the Arcade.ai repo, and all community toolkits will live in this folder. It will be inside Arcade.ai/toolkits. So for example, we will be creating a new one and contribute the Mastodon toolkit to the repo. Right? There are just a couple of changes that you need to consider when starting your project. So let me first clone the repo. Git clone Arcade.ai. I'll go ahead and go into Arcade.ai/toolkits. And from here, I'll go to the Arcade docs, go to create a toolkit, and I will copy this command all the way to Arcade new, and I will replace arithmetic with Mastodon. Go back to the terminal, I paste this, new Mastodon. This will ask me what the toolkit will do, and will say allow the agent to interact with a Mastodon server. My GitHub username is optional, the email is optional, so I'm going to leave it out. I do want an evaluation directory, and this is a question that you only get if you are in our repo. It says, is your toolkit a community contribution to be merged into Arcade.ai repo? I will hit yes, and the only difference is that I'm going to get specific files that I would not get otherwise. So let me go into Mastodon, and what it added is the pre-commit config, the rough toml, which follows the format in which Arcade maintains their own toolkits. So with this in mind, I want to take you to Mastodon's documentation. And here I want to go to obtaining client app access. So this is what we are going to do to create a new Mastodon client app. And I'll be using, in general, the official Mastodon.social server. You can use any server you want, and I will make it so that the toolkit that we built is configurable, so that you can point it to any Mastodon server you prefer. The way this works is that we are going to make a request to create a new application, and we're going to call it test application. I will configure the redirect URIs with the Arcade callback to make it easy for me to later add this as a custom OAuth provider that we can connect to through our tools. Let me copy this, and I will create a new. I can just open cursor in this folder, and we start developing. So I will create a new script here. I'll call it create Mastodon app sh. I'll copy this. I'll call it Mateo Mastodon app. And this I need to replace with Arcade's of callback. And that I can get from Arcade docs. I came to the customizing of section, OAuth 2, and this is the URL. I copy it, I go to our editor, and I paste it here. I will just configure this as my own website. And I will change example to social as suggested by cursor. These scopes are quite general, but in the tools, we can be as restrictive as possible, following the least privilege principle. So I will just add some permissions to that file, run it. So in the reply here, I get what I need, which is the client ID and the client secret, which I will use to configure a new OAuth provider in Arcade. So let me just copy this, and I'll go to the Arcade dashboard, OAuth providers, add OAuth provider, custom provider, I'll call it Mastodon, Mateos, Mastodon app. This is the client ID. I'll copy the client secret. I believe this is, let me just confirm this. It's Mastodon of token, yes. So I'll copy that. This is going to be the authorization endpoint. Confirm that. Verify credentials, token. Yep. This is the token endpoint. And we should enable PKC settings as Mastodon supports it. And it's going to be SHA-256. With this, I can create the app. And we have it created here. Right. So now we can log in against this specific provider from the tools. Let's go back to our editor. We'll just clean the terminal. Let's remove it. Before I start developing the tool, I want to install all of the dependencies and set up my environment. And for this, I will open a new terminal. If I run make, I get a couple of utility commands that I can use. The first one is make install, that will install the UV environment and all packages with their dependencies. So now my Python configuration has been created with a virtual environment, and that I can activate it. So now everything runs inside this new Python environment that will make it easy for me to iterate quickly while building my application. So we get built-in tool here that is called say hello, and it just receives a name and it will return to the LLM hello and whatever name you passed. This is not so interesting as the tool does not require any authentication or secrets or anything. I want to make it so that all of our tools are configured to a specific Mastodon server and also require the specific scopes defined by the Mastodon API. As I alluded to in the beginning, I want to be inspired, or I want to replicate the functionality of our X toolkit. So let's see how that integration looks like. I go to Arcade Docs, Integrations, Social and Communication, X. So basically we are trying to replicate all of these. Post tweets, delete tweets, search tweets by username, by keywords, and look up by username. In Mastodon terminology, of course, we don't have tweets. They are called statuses. So we can actually go ahead and see how that looks like. So these are our API methods. These are called accounts, profile, statuses, right? So we will start with post a new status to Mastodon, right? It's a quite simple REST API. We see a post to the API v1 statuses HTTP 1.1, and these are the parameters that we must use. So we are required to provide an authorization token as a bearer token, which is exactly what Arcade will provide from the cloud. And we may provide an idempotent key and the status, right? So the status in this case is going to be a string, which is the exact thing that goes, or media IDs if we have attachments. To make it easy for now, I will just support the status parameter, but I encourage you to then take this code and enrich it with media attachments, polls, and so on. So this is what the response looks like. And I want to show you a status. Has a lot of attributes, and this is quite normal for a social media app. The response objects are quite large, so we will have an utility function that reduces this into something that is effective for the LLM to consume. So we reduce the context size as much as possible, and we just get what could be useful for the LLM. So let me start with this, and for this implementation, I will get rid of the hello.py, and I want to have a new script that I'm going to call statuses.py, and all of the statuses endpoints will be handled here. So let me just make this terminal a little bit smaller. I want to import annotated. I also want to import Arcade.TDK. I want to import our decorator and the tool context. The tool context is a place where we can get information from Arcade itself into the tool. These are things that should not be revealed to the LLM, like secrets or OAuth tokens, for example. So it's a way for the Arcade engine to communicate to the tools things that should be confidential but are needed by the tool to function. Then from Arcade.TDK, errors, I want tool execution error and also retryable tool error, right? So tool execution error indicates to the LLM and the developer that something went wrong with the tool, and we have an opportunity to put a message for the LLM and a message for the developer that is distinct from that other message. In the message for the developer, we can reveal some secrets, reveal the identity of the user, because we are safe that only the developer will look at that and not the LLM. There is no risk of filtering information out to the public. A retryable tool error has the idea of letting the LLM know that something easy to fix went wrong, like you put the wrong ID or something like that. So it's effective to make the LLM try again when that makes sense. So we have these two different errors that we want to support. Then from Arcade.TDK auth, I want to import OAuth 2. And with this, we will define OAuth requirements for the tools. I'm going to create the first tool. And I'm going to start with the decorator. And I'm going to say requires auth. And it requires auth 2. And I'm going to configure what I want, right? So this ID is going to be Mastodon, which is the same as the ID I configured on the dashboard. And the scopes for this will be right. Okay, actually, I want to put it's right statuses, right? So this is the scope I need, and I also require a secret. And the secret is going to be Mastodon instance URL or server URL. Right? So these two are the requirements for the new post status function to run, right? When the LLM invokes this tool, Arcade will check whether we are authenticated to Mastodon with the right scopes and whether this particular secret exists in our configured instance of Arcade. And if it doesn't, it will reject the tool call, right? Then if all of these conditions are met, only then the code inside this function will execute, right? So I'll get a tool context and the status, that's correct. But I want to annotate the status, right? So I'm gonna say status is annotated string and is the status to post. And I want to return annotated dictionary, and this is going to be the status object from Mastodon. That's correct. And yeah, so from here, so forget about this, which is not what we want. This is how a complete signature looks like. We have the context from which we can retrieve information about what we require and about the user itself. We have the parameters that we need and will be exposed to the LLM as what the LLM needs to fill in. And we have the return. These annotations make it easy for the LLM to understand how the tool functions, right? And this docstring will be parsed as the description and will also be exposed to the LLM. So this is very important and very easy to understand. This is how a complete signature should look like, right? All of the decorators and all of the things, these are all integrated into the signature, so you don't need to keep the description and the parameter configurations or objects separate from the function. All of these will be extracted from the signature, and it will be easy to just pass it around to multiple LLMs and contexts. Before I continue, I want to add some utility functions to my toolkit. So I normally do that here. So we would say utils.py. I don't normally like to put it inside the tools. I want to put it on the toolkit level, but how you structure your toolkit is up to you. I just want to have a couple of utility functions that will help implement the pattern that I will normally use. From Arcade.TDK, import tool context, which is normally I want to build like headers from the tool context. And from also Arcade.TDK errors, or tool execution error, which is if something doesn't exist for some reason. Then from typing import any, I'll tell you why later on. I'll be implementing like 3 or 4 different utility functions all together here, and I'll explain how I will use them together. So if you want to skip this part, it's fine. These are mostly utilities to make development of the toolkit actually faster. So I'll get headers. That's exactly what I want. And it's going to be build headers for the Mastodon API requests. And I'm gonna go token is context get auth token of empty. So if not token, that's correct. If we don't get a token, we have a tool execution error. Otherwise, we get the value and we use it as a bearer token, and we need to set the content type to application JSON. So this is correct. That's our first function. I also want a function that will help me build the URL for the API. So it's going to be get URL. And here again, I want the context, and I want the endpoint, and I want the API version. And I want the default value to be v1, and it will build the Mastodon. That's pretty good actually. But I actually want to the server URL except value error, raise to execution. It's not set. And the way I would normally want to get this is, I want to make it more concise actually. So let me just return from here, and I'm gonna say return get secret. Just make it an F string. API version, and that's correct. That's what I want. So if I don't have this, we'll say Mastodon server is not set in the secrets, and we should never hit that, but just to be safe. And I want to also parse the status into something smaller. So this is going to be status is a dictionary from string to any, and we return a dictionary from string to any as well, but we will filter some of the things. So this is going to be filter out unnecessary status object. Let's get what the status object looks like. So we want the ID, we want the content, we want created at. Let's start with those. So I'm gonna return status, or to return a dictionary, and it's gonna be ID, status ID. Let's see if that makes sense. So URL, do we have a URL? Yes, we do. ID, content, created, visibility. I don't think we care about the visibility. Let me just check what is the visibility here. Visibility, description, public, unlisted, private. Okay, yeah, we do want to keep the visibility there. Or we can just assume that everything is visible. Let's keep it for now. Mentions, I don't care. Tags, I do. I want media attachments. I also want information about the author. Let's see what we get. Author, status, see also. Example, application, account. Oh, it says account. So we want some information from the account. And I normally would like the author, like I'm going to call the account ID, the account username, and the display name, and that should be fine. So I'm going to say account ID, account ID, then username, and display name. We just get ensure display name, username, and ID, and I think we should be fine with this. Mastodon user IDs or usernames can be complex. Then I think it may be worth adding this as well, because it could come from a different Mastodon server, but we can figure that out later. For now, I think this is enough. Essentially, what I want to do here is reduce this dictionary to a smaller dictionary, and the media attachments will be, they will have their own set of dictionaries inside, but they come with images or references to different URLs, and I think that could be handled by the LLM just fine. So for now, I think this is good. And I want another utility function that parses statuses, and it's just gonna call the previous function in a loop, right? So yeah, that's basically what I want. So for statuses, which is a list, it will filter out unnecessary fields and reduce a list of statuses into a list of smaller dictionaries. That should be it. That should be all that I need, I think. I'm gonna use HTTPX as, okay, yes, I do want that. And I'm gonna import HTTPX as the library I use to interact with the API directly, or my REST client, async with, that's correct, that's gonna be my, I want to say client HTTP, and the response is gonna await for a pause to get context statuses, but I want to make these more explicit. Context like that, I want this to be the endpoint, right? So I normally want to make the code easy to read from where I am. And while it's clear what happens if I just pass the context because I know what that is, statuses could be, not obvious that it's an endpoint. So I want to make it clear that, okay, no, this is what I refer to. So we get the headers and we pass the status, raise for status, which is exactly what we want. And then we return parse statuses, responses. Okay. So this should be enough to get the first thing started. Let me just, apply HTTP. So I will save this for now and we can start testing this. So I'll go through an entire flow with this one tool and then I'll keep adding other tools as we go along. So let me just open the tests and I'm gonna say test statuses.py. And let me just show you what is included. You will see that this is essentially a regular unit test, and it will say, test hello, test hello for raising errors. So in general, I would like to have at least one test per tool at a minimum. More are of course better, but I will have at least one per tool. I will get actually rid of test Mastodon.py because I'm not using the built-in hello tool. And I will start it from scratch. So I'm going to say from unit test import magic mock, import httpx, import pytest, from Arcade.dev errors, import tool execution error and also retrieval tool error. And then, post status. This is pretty much what I want. I guess this is all right, but I actually want to get some fake data here, right? So I'm gonna go ahead and copy some values that I had before. So I prepared this beforehand. So let me walk you through it. And I think this actually should be count. Okay. So let me show you what I got here. I got a very long text. By default, Mastodon servers support up to 500 characters. So this is a truncated static test. This is the full status that I wanted to initially publish. This is a fake account that I just created and it's a copy of this dictionary essentially, and I just put some examples, random IDs and all of that. Fake status response, which comes from also their documentation, which is pretty much similar to this. I just changed some of the values, not to have like Gargron or something. And a fake parse status, which should simulate the output of like this specific output, right? So with that in mind, I want to test post status success, right? So the context, I want to make it, I want to call it tool context, HTTPX mode, that's all right. And this is, I don't want to type this tool for now. So the mock, I want to start with a mock. Mock response is magic mocks. Status code is 200. Fake status response. I want the HTTPX mode post return value to be the mock response. Then I want the status to be hello world. Status is going to be status assert called once. and that should be fine for now. I want to configure some fixtures, and for this, I will add a new file, and I'm going to say conf.py. So this is going to be port pytest from Arcade.dev import to context and to secret item, so that I can mock these two. Pytest fixture. This is going to be the tool context. When we return to context, authorization is going to be token, test token, and secrets. This is almost good, but it's going to be a list of tool secret item, and the key is going to be Mastodon social. That's correct. So this is what I want for the tool context, and I want another one. It is fixture HTTP xmux, and that's gonna return. For now, I will just not type this. So mock client is going to be mocker patch. That's correct. And then auto spec is true. Async. Actually, I want to receive a mocker here. Async mock client return value enter return value return async mock client. So this makes it easy for me to mock the async behavior of the async client. So this will be async enter and return value, right? Because this is just a promise and this is the actual result after I await. I think we just need to make test. Okay, something failed. This is called context here. What did I do wrong? Parse statuses. So, oh, sorry. It's because I need to only call that. And parse status. It's because this doesn't have the visibility. So for now, we'll just remove that from here. And then let's test it again. Test. So we passed the test. That's test-driven development for you guys. At this point, I'm happy already about this tool. It should post to Mastodon just fine. We can test this already. And before that, I just want to add at least one evaluation function. For this, I'm going to use eval Mastodon because I'm going to make just one evaluation case per tool. So let me show you this. This is the eval Mastodon. This is what will change. Post status for now. I will just remove that. We have an evaluation rubric that essentially says we are going to add some cases and this will be run a number of times. And we are testing whether the LLM can choose the right tool for the job and also put the right parameters into calling these functions. We consider anything below 85% to be a failure. So if you put this into your CI/CD, then this will actually prevent you from continuing. You have to fix your toolkit. Anything above 85 will pass, but something between 85 and 95% will be in the warning threshold, right? So this is something that you need to pay attention to and maybe not fix today, but do add something to your backlog on polishing the tool so that it works better in the future. This will be very catalog dependent. So what I'm going to do now is add one evaluation function for just a single tool, which is not very representative of real world scenarios, but it will become better as we add more tools into this toolkit, right? So here it will say Mastodon tool evaluation. Yeah, this should be fine. I will just remove this case and or replace values in this case. So this is gonna be posting a status. The user message is post status to Mastodon saying I don't want hello world here. I want something like hello world from an AI assistant or something like that. Like something that makes sense, right? So what we said here is the expected tool call. So we are expecting the LLM to predict two things. It should choose post status as the function, and it should choose this argument, right? So status, which is our keyword argument for that function, and the value should be inferred from the context, which is this same thing, right? The rubric will be this one, which determines that failure is anything below 85% and warning anything below 95%. We want so the similarity critic is the one that we normally want to use for text. It will have it will run cosine similarity by default, saying how much it should behave, how much the value should be similar to whatever we put here, right? So we can also add here additional messages, which is, context for the LLM. But in this case, I don't think we need it because the user message here is everything that the LLM should require for this, right? So it doesn't really need to know that my friend's name is John Doe or that it's great that you have a friend or whatever. Like it should not have this mini simulation, if you wish, right? So I'll remove that. I will leave the similarity critic over there, and I will change the weight to 1.0, right? As a general, the critic field should be actually status, right? In general terms, I normally want, you can have multiple critics, like especially if you have multiple arguments. And as a rule of thumb, I like to make it so that the weights over multiple critics sum to 1. You don't have to, but it's the way I like to think about it. So I have a little distribution there on how important things are, and they all sum to 1. It's a normalized vector. I like it. Right. So with this in mind, we are ready to do testing, which already passed, and evaluations. For the evaluation, however, we need to actually serve this, right? And the way I'm going to do that is going to be with a tool called ngrok, right? So I'm going to do arcade serve, and that's going to start a server with our single tool now, and it's running locally in my port 8002. And I'm going to go to my terminal, I'll open a new one, and I'm going to call ngrok HTTP 8002, right? So what this does is it gives me this URL that is pointing to my localhost at the correct port. I can use this to configure a new worker, right? So I do this in order to evaluate against Arcade's cloud. I could also do it by self-hosting the engine, but I don't want to complicate my life right now. So I'll just add a worker here. I'm going to say this is going to be my Mastodon worker, right? It's going to be an Arcade worker, and the secret is going to be dev, and I can just leave the timeout and retries with the default values, right? I added the thing. It already recognized that the status of this is healthy. And if I go to the tools, it says, yeah, it requires Mastodon, which is satisfied by the OAuth provider that we added earlier in the tutorial. And it requires the Mastodon server URL, which I didn't configure yet. So if I go and click on that, I see that, if I go to tools, I can see that this is the missing one. I click here and it will auto-populate this. This is going to be main Mastodon server, Mastodon social. I have an account here that we are going to use to test, that's going to be our value. Paste that in and submit. So I created that. I just want to make sure that in our code we handle that. Yeah, so I added the wrong value because we are adding here this slash. So let me just go ahead and edit that like that, submit. Okay, we're fine. So this should work now. So I'm gonna open a new terminal. And this will be Arcade eval. Let me see how it works. So this is part of the CLI. I will point it to this directory, the evals directory, and I will use the cloud flag, which essentially just configures the default cloud engine, right? So I'm gonna say Arcade evals cloud evals, and that should start. Right. So the report says that it passed, but it was not a difficult evaluation. It's GPT-4o by default, and it ran with 100% accuracy. As we add more evaluation cases, this may go down, but the idea is to keep this consistently high, right? Since we are serving this, we can already test our tool in real action. So let me do that from the playground. So from the workers page, again, I can go to my Mastodon worker, tools, and then I see the only tool available is post status. I can execute from here, and I will say hello from the Arcade dashboard. I execute the tool, and it will open the OAuth flow for me to authorize or deny. I will authorize, and it says done. You cannot close this window and return to the application, right? So that should have created a new post, and this is the post that we got. So we can actually, copy this and post it on my behalf. I can just go ahead and see that hello from the Arcade dashboard, right? So that's the flow itself that we normally follow. So what I'm gonna do for the rest of the tutorial is add these tools. You will probably see me in an accelerated video as I type all of the remaining tools, but I will pause once I go to test and once I go to evaluate. So let me get started. Here I wanted to pause because the search recent statuses by username tool will depend on a tool that I didn't write yet. So I wanted to make this into a pattern and explain why this is important, right? In this case, something that a human may do is go to a Mastodon account and look up the recent statuses, right? There is no direct way to do this from the username, but it's not intuitive for a human or for an LLM to get the recent statuses by the user's ID or the account ID from Mastodon, right? You would normally say something like, give me the latest statuses for this handle, this user, search for this account, things like that. So for LLMs, and this is part of what we call machine experience engineering, the idea is to, instead of implementing tools as API wrappers, is to implement each action as a tool. And the action is way closer to how a human may think about using a service than a developer using an API. And this is one of the common patterns that emerges when you implement intent-based or like action-based tools that may require, getting, in this case, the account information to extract the ID from username, right? It also gives us things like the scopes that are needed. In this case is read for statuses, but also read for accounts, because there are two operations that go into this specific action, right? And the LLM does not need to know about all of these complications. So I'm going to go ahead and implement the lookup single user by username and finish this implementation. And I'll do that in a new file that I'm going to call users.ui. Here I want to pause again because it's the first time that I'm gonna make a differentiation between the tool execution error that will go just to the LLM and the one that will go to the developer, right? So in this case, I don't have to, but I think it's good practice to add more information to the developer, right? So I'm gonna say developer message. In this case, it's gonna be not found while searching for recent statuses, right? They will get more information and they will know that this is the tool invocation that was attempted, but it's useful for me to make this difference and think about, okay, what would the developer care about that the LLM doesn't, right? Here I'm going to pause again because in this case it's something that the LLM may decide to retry. So I'm going to do a retryable tool error, and it's going to be one keyword or one phrase must be provided to this tool, right? So this is essentially like another prompt that will go into the LLM to indicate what went wrong. And then I can get the developer message, which in this case, the LLM did not provide any keywords or phrases for recent statuses. That's correct. And we can also have like an additional prompt content, right? So it can say like, please provide at least one keyword, one phrase to search for recent statuses, right? So this will also indicate to the LLM what should happen, right? And then we can have a try after, something like half a second, right? So this is to not overload the service with multiple retries from the LLM. From this point forward, we can just continue implementing the tool. So with this, we have pretty much the tools that we need. We have post status, delete, lookup by ID. So these are the single ones, and the multiple ones, which are search recent statuses by username and search by keywords, which I believe are the same that we support in our X toolkit. So post, delete, search by username, search recent tweets by keywords. This is the one for the user, and lookup tweet parity, right? So we achieved parity with the X integration, and we now need to add the tests and the evals, and I'm going to go ahead and do that in the accelerated video. Another important thing is that because we want to test this function as well, we need to mock the other tool. Let me show you how to do that. So in the const test here, we need another fixture, Python fixture, and it's going to be dev mock single, lookup single user by username. We mock the tool. It's going to be mocker patch. Okay, Mastodon users. Actually, because we are calling it from the statuses, we change this here, and we don't need the auto spec. Forget about this. Return the mock tool. So with this, we will be testing only the search recent, assuming that this will return a real user or something. So we can go back and keep on with our testing, right? So far I added successful tests for the test post, post status and delete status by ID, and I can carry on with the remaining ones. For this one, for example, I will also add a failure case, right, which is important. So now we have a comprehensive suite of tests that will test the post status, delete, search reason by username, by keyword, with different successes and failures, and also the lookup status by ID. So we have covered all of our functions with tests. So let's test it. And it's time to fix some of the functions. So now that all of our tests have passed, I'll go ahead and add more evaluation cases. This is the first use case. This is the first evaluation case where I need two different critics. So I'm going to use the similarity critic for the username in this case, and a numeric critic for the limit. This is another interesting case where the keywords argument is a list. So I just want to test whether the keywords argument was inferred by the LLM correctly. So for that, I'll use a binary critic. I think our evaluation suite is complete now, so let me run the evals. This is interesting. Of course, since the last time I served a toolkit, I've added many tools. So it's time to serve these again. So I stop the server, I install again, I serve it again. So I should see 6 tools now. So the evaluation passed, but I got some warnings. I want to check what happened. Username known, status ID. It should be status ID. By status ID. Status ID. Username limit. Keywords. Make sure all of them are matching. It has now passed all of our tests. We only need to test users now, the one function. So I'm gonna test users by in magic mock. This HTTPX username. I want from k errors tool execution error. I will also copy the fake account here. And then it's going to be the same. So this is going to be that's correct. And go once. Small phone, not phone 4. Circle once. Right. So with this, make test, and we are fine. So all of the we now can get a coverage report. So we are at 99%, which I think is quite good. So let's see what else make has for us. So we can say make check. It will run some quality tools like MyPy. So this is good to know. We say we are returning a list of these. Actually, we are just returning a dictionary. So let's fix that. Check again. And we are fine. Let's see what else we can check. BL coverage, install level, data. So this was the way to make this. I will not submit this for review and see what happens when we do that. Once I'm confident that my toolkit works, it's time to contribute it back to Arcade. I will start this process by deactivating the virtual env that was installed inside the toolkit, and I will go to Levels Up and follow the documentation from the Arcade repo. That is uv sync extra all dev, like this. Then make test. Then make check. Then make build. Since everything looks okay, I will create my own branch and then make a pull request. The only thing to commit should be the toolkit, so I can just go ahead and say git add dot, and it will just be a couple of py files and the toml and YAML files. Once I do this, I see that the linting is having a problem. So let me go ahead and fix that. With this git push origin and with this we can go ahead and leave a message. I create a pull request. And I will request engineering to review. With this, I will wait until the Arcade team reviews the PR and then implement any comments that they may have.